Okay, Shimti Tessera and Vellamo Planitia are adjacent quadrangles located in the northern plains of Venus. Excuse me. I partially mapped these quads as part of the original Venus data analysis program some time ago, and at that time described and interpreted a proposed new map unit, shield plains. Subsequently, over 20 mapped Venus quads in other regions of Venus have also identified a similar shield plains or shield terrain unit. So the goal of the new geologic maps was to provide observations and insight on the shield plains unit in its type location. Map packages have been submitted and are awaiting the next step. Next slide. Next slide. Great. The map units were defined on the basis of all of the Magellan data sets. And the youngest units in both quads are lobate or digitate plains associated with the large volcanic centers. These are shown in orange. Intermediate stratigraphic units are actually the most extensive units in both quads. These are the shield plains shown in purple and the regional plains shown in blue. And the regional plains overlay the shield plains. The oldest units, of course, include Tessera, which is directly overlain by the shield plains. Next slide. Okay, the shield plains unit, PSH, in these quads. It's a major unit with consistent stratigraphic relationships. Shield plains unit is defined as consisting of the multiple small shield volcanoes and associated eruptive material. In the radar image that's shown here, this is a portion of the northwest corner of V-12. And you can see the shield plains embay and in some cases flood the Tessera and are in turn themselves embayed and in some cases surrounded by the regional plains. One interesting aspect is a near absence of organized patterns of shields or alignment of shields in the shield plains, which appears to indicate no pervasive structural control. Next slide. So before we can talk about the shield plains, we need to actually get a quick look at the two different types of occurrences of small shields on Venus. Early in the Magellan mission, small clusters of tens to hundreds of small shields were identified pretty much all over the planet and identified and named as shield fields, following the terrestrial volcanic field analogy. These have since been mapped stratigraphically throughout Venus geologic history and are interpreted as melt areas of limited extent. The shield plains are something very different. Many, many small volcanoes distributed relatively uniformly over a very large surface. Consistent stratigraphic relationship in most mapped locations. The suggested analog Snake River Plains shield volcanoes or oceanic seamounts, and interpreted to be volcanism associated with widespread melt. Next slide. So what are the significance of the shield plains in Venus geologic history? Are they a local, regional stratigraphic unit, as some researchers have suggested? Or are they a global stratigraphic marker unit, as other researchers have suggested? Clearly, they represent a major regional stratigraphic unit and a very specific style of resurfacing. And they have been discovered in multiple locations on Venus and appear to occur in the same stratigraphic position. But what is that stratigraphic time period? Is that stratigraphic time period the same absolute time everywhere on Venus? More detailed mapping of regions on Venus hopefully will yield evidence and observations that will help answer this. But to answer this definitely, we need some way to assign absolute stratigraphic time on Venus. So that's something we all need to talk about